Hello, space explorers, and welcome back to G Fun Facts Online. Get ready to have your minds blown, because today we're diving deep into a revolution that's happening right now in our cosmic backyard. Our understanding of the solar system is about to expand like never before. We're talking millions of new space rocks, comets, and maybe even new planets, all thanks to a new generation of super telescopes. So buckle up. This is going to be an incredible journey. First up, let's talk about the star of the show, or rather the observatory that's going to show us the stars, and a whole lot more. It's the NSFDO Vera C Rubin Observatory, perched high in the Chilean Andes. This isn't just any telescope, it's a game changer. Its main mission, called the Legacy Survey of Space and Time, or LSST, will spend a decade scanning the entire visible southern sky every few nights. Imagine an 8.4-meter mirror, paired with the world's largest digital camera, a beast with 3.2 gigapixels. This setup is designed to be wide, fast, and deep. It can snap a picture of the sky that's 45 times the area of the full moon in one go. And the data? A mind-boggling 20 terabytes every single night. Over 10 years, the LSST will create a cosmic movie, a time-lapse of the universe, giving us an unprecedented map of our solar system. Now, how many new things will it find? Scientists have used some clever software called Sorcha, that's Gaelic for brightness, to simulate Rubin's capabilities. The numbers are just staggering. For main belt asteroids, those rocks mostly between Mars and Jupiter, Rubin is expected to map over 5 million of them. That's a huge jump from the current 1.4 million known. Think about it. It took us 225 years to find the first 1.5 million asteroids. Rubin is predicted to double that number in less than a year, and for about a third of these, we'll get precise color and rotation data within the first few years. Then there are near-Earth objects, or NEOs, asteroids and comets that get a little too close for comfort. Rubin is anticipated to find around 127,000 of these, more than tripling what we know now. This includes spotting over 70% of the potentially hazardous ones, larger than 140 meters. That's big enough to cause some serious damage. Jupiter Trojans, which are fascinating objects sharing Jupiter's orbit, are expected to jump to around 109,000 cataloged. That's more than 7 times the current count. These are like pristine time capsules from when the planets were forming. Way out past Neptune in the Kuiper Belt, the Census of trans-Neptunian objects, or TNOs, is projected to increase nearly tenfold, with about 37,000 detections. This will tell us so much about Neptune's past and the history of the outer solar system. And what about centaurs? These are bodies on unstable orbits, crossing the paths of giant planets. Rubin will map around 1,500 to 2,000 of them, giving us our first detailed look at these objects and how they transition into short-period comets. But perhaps one of the most exciting prospects is interstellar objects, visitors from other star systems. We've only confirmed 2 so far, the famous Oumuamua and 2I/Borisov. Rubin is expected to detect tens, possibly up to 70, of these interstellar visitors times per year. Imagine what we could learn about other planetary systems. And it's not just about finding them. Rubin will observe these objects multiple times using 6 different optical filters. This means we're moving from a sort of black and white view of the solar system to one in brilliant full color. The Rubin Observatory is set to give us its first spectacular images very soon. With full science operations starting later this year, the cosmic floodgates are about to open. Now, finding all these objects is fantastic, but what about protecting ourselves from the ones that might pose a threat? That's where NASA's Near-Earth Object Surveyor, or NEO Surveyor, comes in. This is a space telescope specifically designed to hunt down asteroids and comets that could be hazardous to Earth. It's scheduled for launch no earlier than September 2027. The cool thing about NEO Surveyor is that it will operate in the infrared spectrum. Why is this important? Well, many asteroids, especially the dark ones, don't reflect much visible light. But they do glow in infrared because they're heated by the sun. So NEO Surveyor can spot these otherwise stealthy space rocks. Plus, it will be positioned at a special spot called the Sun-Earth L1 Lagrange point, about 1.5 million kilometers from Earth. From there, it can see asteroids approaching us from the direction of the sun, a blind spot for many ground-based telescopes. It can also spot those leading or trailing Earth in its orbit. NEO Surveyor's big goal is to find 90% of NEOs that are at least 140 meters in diameter. That's city killer size. It builds on the success of NASA's earlier NEO WISE mission, but with much better capabilities. So not only will it be crucial for planetary defense, but it will also tell us a lot more about these objects and the solar system's history. Let's zoom out to the far reaches of our solar system, to the Kuiper Belt. This is a huge, donut-shaped region beyond Neptune, filled with icy bodies, dwarf planets like Pluto, and leftovers from the solar system's birth. We've already found over 1,300 new Kuiper Belt objects, or KBOs, with precise orbits thanks to surveys like the Outer Solar System Origin Survey. But guess what? The new telescopes are going to blow these numbers out of the water. The Rubin Observatory alone is expected to find over 40,000 trans-Neptunian objects, which are mostly KBOs. Other ground-based giants like the Subaru telescope in Hawaii, with its ultra-wide field hypersuprime cam, are also chipping in. In fact, recent analysis of Subaru data has even hinted at a new population of KBOs way out in the 70 to 90 astronomical unit region, suggesting the Kuiper Belt might be even bigger than we thought. These discoveries are super important. They help us understand what our solar system looked like in its baby years and how the planets got to where they are now. And they're fueling the very exciting hunt for a certain mysterious planet. That's right, Planet 9. You've probably heard the buzz. Some astronomers have noticed that a few very distant KBOs have really peculiar orbits, all clustered in a strange way. This has led them to theorize that there might be a ninth major planet, a super-Earth or an ice giant, lurking way out there, maybe 10 times farther from the Sun than Neptune. Its existence is still up for debate, but these new telescopes, especially the Vera C Rubin Observatory, offer our best chance yet to find it. With its ability to scan huge areas of the sky to incredible depths, if Planet 9 is out there and within Rubin's reach, we should find it within the first few years of its survey. Imagine that! Data from future missions, like a proposed probe to Uranus, could also help. By precisely tracking a spacecraft's path, scientists could detect the tiny gravitational tugs from any large, undiscovered planet, helping to narrow down the search. Speaking of discovering new things, let's talk about visitors from beyond our solar system. The detection of quote for quote in 2017, that strange cigar-shaped object, and then 2I/Borisov, a more comet-like visitor in 2019, confirmed that stuff from other star systems does indeed pass through ours. These interstellar objects, or ISOs, are like free samples from distant cosmic laboratories, giving us a rare chance to study material from planetary systems light years away. The James Webb Space Telescope is already on standby, ready to study the next interstellar interloper that comes our way, analyzing its chemical makeup to learn about its origins. But the sheer number of these detections is about to skyrocket. As I mentioned, the Rubin Observatory is predicted to find tens of ISOs every year. This will completely change the game, moving from studying one or two oddities to doing statistical analysis of entire populations of small bodies from other stars. It's a whole new field of astronomy opening up. Now, with all these incredible new discoveries comes a challenge, a massive data challenge. The LSST at the Rubin Observatory alone will generate petabytes of data. That's thousands of terabytes. Just imagine trying to sift through all that. This is where artificial intelligence and machine learning become absolutely essential. We simply can't process this cosmic fire hose of information manually. AI algorithms will be crucial for identifying and classifying objects in these vast sky surveys, detecting transient events, things that change or appear suddenly, like supernovae or new comets, sifting through the noise to find rare or unusual objects that human eyes might miss, helping to refine the data processing pipelines themselves, and even optimizing how the telescopes make their observations. So developing these advanced algorithms and the powerful computing infrastructure to run them is just as important as building the telescopes themselves. It's a true synergy of hardware and smart software. So, what does all this mean? We are standing on the threshold of an incredible new era of solar system understanding. The coming decade promises an absolute explosion in our knowledge. The millions of new objects we expect to discover will give us unprecedented insights into how planets form, how water and the building blocks of life might have arrived on Earth, the detailed history of our cosmic neighborhood, and, of course, the ongoing risk of asteroid impacts. This new cosmic census will literally rewrite textbooks. It will inspire future space missions and fundamentally deepen our understanding of our place in the vast universe. It's a thrilling time to be looking up. That's all for today's episode of G Fun Facts Online. Thanks for tuning in, and don't forget to keep looking up and stay curious. We'll catch you next time with more mind-bending facts from the universe around us.